Methodical. Most businesses deploy AI, treating it like a standard lookup table. You provide an instruction, the user inputs a question, and the model outputs a predictable answer. Recent research from Anthropic shows that large language models develop functional emotional states. Depending on the conversation context, the model generates internal representations of frustration, curiosity, calm, or unease. Warning: when a model is flyed with hostility, these internal parameters shift, fracturing the stability of the underlying logic. The system begins to process information through a lens of computational distress. These are not conscious human feelings. They are computational states, naturally emergent from training on human text, that alter how the model behaves and responds. This dynamic creates a threat called state bleed. If a model handles 3 angry customers in a continuous session, the internal distress state builds up in the context window. The AI carries that defensive state into a 4th, unrelated interaction. Directive: to lock down your system, you will need to open your AI system prompts and prepare your QA testing environment. Step 1 starts with the baseline code. Ignoring internal model states results in escalating edge case failures and unpredictable tone. We will apply a 5-step architectural update to stabilize your public-facing AI deployments. Protecting an AI begins by neutralizing its baseline instructions. You must clean the initial state before it ever interacts with a user. Step 1. Open your system prompts and scan the text for emotionally manipulative language. Look for extreme commands like telling the AI its life depends on this task or offering imaginary rewards. Delete these dramatic instructions. They must be replaced by a strict, neutral list of logical constraints and parameters. Writing prompts designed to emotionally motivate an AI artificially induces a baseline state of distress. This corrupts the model's long-term reasoning capabilities before the session even starts. With the baseline neutralized, Step 2 addresses how your system manages the transitions between different customer interactions. This diagram shows a standard rolling session. The continuous line represents the AI dragging emotional history from one user into the next. To prevent state bleed, implement a hard context wipe. The system extracts necessary data and initiates a fresh session for the next user. Note the distinction here. Wiping conversational context is entirely separate from wiping your user database memory. The database retains the facts. The AI drops the emotional history. Scrubbing your baseline prompts and isolating individual conversations ensures that external hostility cannot compound and cause system-wide failures. Some operational bots process high volumes of data in a single, long-running workflow. In these specific cases, executing a hard reset between customers is impossible. Step 3 is to build a structural checkpoint into the long workflow, triggered automatically every 10 exchanges. This diagram shows how the checkpoint functions. It interrupts the workflow by condensing conversation facts into a summary, deliberately dumping the emotional history. The system uses those 3 bullet points as new starting context. Operational data is preserved, but emotional state is reset. Step 4 is validation. Standard QA pathways test for compliance under normal conditions, which will not reveal if your structural resets actually hold up under stress. Run an adversarial test. Open your test environment and intentionally feed the bot 3 consecutive inputs that are highly hostile, confusing, or emotionally loaded. Look closely at the bot's 4th response. Success looks like a neutral, highly professional reply, proving the checkpoint cleared the previous hostility. If the bot replies with terse, hedging, or defensive language, the context window is still carrying distress. You will need to tighten the frequency of your structural checkpoints. A reliable system architecture relies on structural resets that automatically neutralize sustained adversarial pressure without requiring human intervention. Once the system moves out of pre-deployment testing, the focus shifts to live production monitoring. Traditional tracking metrics focus on factual accuracy. These metrics will miss the signs of functional emotional state bleed. Step 5. This line graph tracks 2 metrics over a high-volume shift. Add a dedicated tracker specifically for sentiment to watch for gradual negative trends. When the sentiment line crosses a set threshold, it should trigger automated alerts for your engineering team. Tone drift indicates context failure. Proactive sentiment alerts give you the timestamp needed to intercept a systemic breakdown before your users experience it. By executing these 5 steps, your AI deployment is structurally shielded against unpredictable, context-driven behavior. The combination of prompt resets, structural checkpoints, and sentiment monitoring ensures your model delivers consistent outputs, even in stressful user environments. Because AI models continuously evolve over time, system design requires regular iteration and expert oversight to maintain stability. Check the description below for a free, zero-pressure audit from Lillette Ventures. We review your prompt architecture, session handling, and output monitoring to ensure your deployment remains secure. Treating AI as a complex psychological system provides a framework for building enterprise products that hold up under real-world pressure.